to the curve at a specific point. The limit is the instantaneous rate of change of the function at the time between measurements taken to zero. Is an alternate derivative definition. The derivative is a function and derivative of many kinds of functions. It can be found including linear, power, polynomial, exponential, and logarithmic functions.
Good day. Here's an example scenario where generic derivatives are used in real life. Imagine you are a civil engineering working on a new highway project. Your team needs to design a curve on the highway that will allow the drivers to safely navigate a sharp turn. To do this, you need to calculate the curvature of the curve at various points along its length. The curvature of a curve is a measure of how much the curve deviates from a straight line at a given point. Mathematically, it is defined as the second derivative of the curve with respect to its parameter.
Derivatives are used in fact everywhere, since change can happen anywhere. One example is temperature. We use derivatives to check the temperature variation or simply the change in temperature. When we feel unwell, we get our temperature checked to know if we have flu or illness. Remember, temperature was mandatory during the pandemic? You could notice that before and after a certain period of time, your body temperature increases or decreases depending on your overall well-being and the environment that surrounds you.
John is driving his car along a straight road. The position of his car at time t in seconds is given by the function of s of t equals 3t squared plus 5t minus 4, where s is measured in meters. What is the instantaneous velocity of John's car at t equal to seconds?
To solve the problem, we have a given function of s of t is equal to 3t squared plus 5t minus 4. We need to get the derivatives of every term. That would give us s prime of t is equal to 6t plus 5. We know that t is equal to 2. Therefore, we can easily substitute it to our equation. That will give us s prime of 2 is equal to 6 times 2 is 5. 6 times 2 is 12. 6 times 2 is 12, and 12 plus 5 is 17. Therefore, the instantaneous velocity of John's car at t equals 2 seconds is 17 meters per second.
When 5 feet tall walks away from a lamppost 16 feet high at the rate of 3 meters per hour, how fast does the edge of his shadow move?
So the answer or the solution to the problem. So we will be using a similar triangle principle here. Segment OB is equal to x plus y because line segment OB is equal to line segment OQ plus line segment QB. So then we will just cross multiply and the answer will be 5x plus 5y is equal to 16x. Then we will get the derivatives on every term. 5 dx over dt plus 5 dy over dt is equal to 16 dx over dt. And then we will substitute all known values. Just simplify and isolate dx over dt. So the answer will be 5 dx over dt plus 15 is equal to 16 dx over dt. Then we will factor out dx over dt in the right side. We will divide both sides with 16 minus 5. We'll cancel the 16 minus 5 over 16 minus 5, and after that we will simplify it, and the answer will be 1.36 mph, and that is increasing.